right where you guys are. Good morning, PSAT kids. Hope you had fun. But we are going to go ahead and finish up notes and maybe even have some time for homework. I'm doing a short and sweet version because the seniors are like, psh, we want to work on homework. So, yesterday we learned I have to unfreeze the screen. Implicit differentiation. What's true, Kyle, about all the x's and y's? Oh, I was looking for your, like,
they're all jumbled up.
They're all jumbled up, or I say they're all mixed up. They're all jumbled up. Man, there are a lot left over. They're all jumbled up, or they're all mixed up. Do we have to, everybody, get y by itself? No. Remember yesterday? What was going on in this picture? Why is there a Facebook group?
Let's start getting the differences. We'll do finishing the square.
Why? Why was I doing that? What was I trying to do?
Get y by itself.
And if I got y by itself, what could I have kept doing?
You could have done
Taking the derivative the old-fashioned way, like, let's just go. Yay, it's all in terms of x. Let's go. Yesterday, I got down to about here in period 6, and Tyler Smith was like, can't we just go for it at the beginning? Like, 2y. I was like, yes. But she wasn't perfectly right.
No.
Because the derivative of this wouldn't be just 2y. What would it be? Bring down the 2, make it a 1, but then
dy dx.
Y dy dx? Because the new way of thinking about it is d dx of y is dy dx. Another way of thinking about it is anytime you see a u that has a y, we have to think of u prime being dy dx. So was she right? Kind of. Was she totally right? She didn't think about u prime. She didn't think about u prime. So anytime we see a y expression, yes, we can just go for it as it is. We don't have to do all the crazy algebra if it's even possible, which sometimes it's not. We could just go for it. We could just take the derivative as it is, just start deriving 2y, yes, but don't forget your dy dx. So when you guys see this example, what should we do? Get y by itself? No, just go for it. So when you just go for it, what do you get?
Do you want to keep 3xy squared over there on the equal sign?
Well, here's the struggle. If we subtract it over, it hasn't really changed anything as far as the derivative process, right?
No, but...
And if we start dividing stuff, we're going to make a quotient rule.
But like, if we put it over there, you can have it on one side. If you want it on one side. That's what I'm asking. I know you want...
I guess you could do it either way, Kyle. Either way, you're going to be doing a product rule, hopefully. You're going to be doing a product rule, so whether it's on the right or whether it's on the left, it doesn't make a huge difference. So maybe I'll just keep it as is, so there's one less step to write. So, you guys start talking, go for it. What do we got?
3x squared
Plus?
3y squared times whatever.
CB prime? U prime. Equals? Pause. What should you think?
Quotient.
Who's your box?
3x.
That's what I would do too. Who's your triangle? Okay, so second?
Y squared.
D first?
3.
Plus first?
3x
D second.
2y times
dy dx.
Okay, now here's the question as to whether or not you guys can finish the problem. Take that and get dy dx alone, if you haven't yet. Take that and get dy dx alone. There were steps. I'm going to rearrange this real fast to put the steps up on the screen. What we've done so far. What we've done so far is we've differentiated both sides of the equation with respect to x, watching out for the u prime. Watching out for the u primes.
Can you get rid of one of the y squares by subtracting it? Or is that kind of...
You're allowed to move things on either side of the equation in whatever way is beneficial to you. And that's exactly what this step number 2 is all about. Collecting certain types of terms, ideally on the left side, and collecting other types of terms on the right side. Organizing in a way that will be efficient soon. note, anytime you're taking derivatives of y terms, remember the u prime of dy dx. Why did I do that? I'm allowed to add, subtract, keep, not keep any of the terms the way they are. So why did I do it that way? Why did I subtract the 6xy dy dx, and why did I subtract the 3x squared? Why does the directions, why did the steps say collect all the dy dx terms on one side and all the non-dy dx terms on the other? It's all about step number 3, which says? Because if you get all the dy dx terms on one side, you can just pull them out. If you can pull them out, what can you do next?
You take all that over there.
Mm-hmm. I'm going to pull out a 3. You guys can probably see why, right? I'm going to pull out a 3y.
Can you get rid of?
I can reduce anything that's been factored out. Yeah, I can reduce anything that's been factored out. Yeah.
I'm confused. How did you get rid of that 3x? Oh, just kidding. You multiplied it to make it negative.
This one?
Yeah.
I just did my 3 times 2 is 6, so I kind of rearranged. So 3 and 2 is 6, and then xy. But I moved that whole thing to this side.
Wait, how can you do that? Like,
Oh, just subtraction.
no, I know, but like, how is that legal if it's
This.
alone?
Well, it's community property. Multiplying.
Yeah. So I can rewrite this as 3 times 2. I'm just rearranging the multiplication, and then I'm combining my coefficients. Yeah. You're probably thinking like distribution, you have to be careful, parentheses, but there's no addition or subtraction in here, so I can literally just rearrange and group. Yeah.
Wow, how many wild fun there?
This Mr. Crap. He always has fun. Great guy. He loves Jesus. Oh, you guys will get excited in Chase class, just in a very different way.
Honestly, I love Mr. J's class.
Yeah.
Each year it just got less and less.
Like structure?
Less strict.
No
Yeah.
way. Last year was the least strict, but no. Geometry is so strict. Me and PK would barely even talk. Like, we talk
Because
about
that was
math,
our first year.
and then he would move us across the room.
You guys do talk a lot. Even some of your senior teachers are talking about it.
It's just straight.
I don't talk to
Well,
anymore because
yeah.
no one.
Everyone just sleeps in Mr. Straight.
None of our class is so tough.
Our
Fifth
class
period
is
is more
English.
So tough.
Which one?
Mr. Ruth?
Oh, I didn't feel it.
Yeah, we're
Sorry
gonna
about
it,
it.
so.
We talk a lot too though.
But she talks too.
Yeah,
She complains to us.
She communicates with.
Yeah, she's like, I hate when
I know, but she loves when we talk because she loves
Yeah.
knowing about her life and stuff.
Hey, we're good, right?
Yeah.
Ooh, let's go back and let's solve for y and let's plug in and get it in terms of x. No. Remember what we do? Remember yesterday when we were going over AP Classroom, and it was a silly example, but it was the tangent line one. And I had my line written in point slope form, y minus y1 equals n times x minus x1. And all the multiple choice answers were y equals y equals y equals, remember?
Yeah.
And I was like, oh, we have to get y by itself. Okay, let's go further. That's what you need to do in this homework. You need to see your answer and say, okay, I have an answer. Now, if it's an odd, what can you do?
Check.
Yeah, just go to the back of the book real fast and be like, hey, does it look like mine? If it doesn't, maybe pop on a calc chat. Maybe think, can I simplify? Can I change things? Come back to the beginning. This is a hint. It doesn't help in this one. Come back to the beginning because sometimes, guys, this is true. This is what the entire problem is based upon. Do you remember how We had that weird thing earlier, like a 2 sine x cosine x, that magically, not really it's math, but turned into sine of 2x.
Yeah.
Why? Well, because it's true. That one equals that one. This one's a little simpler in the whoever did the problem's mind, so you can substitute. It's a legal substitution. Now that we have these equations at the beginning, this could make for a legal substitution if there was something. For instance, what if this was x cubed plus y cubed? They could have plugged this in. So there might be, if the answers look, yeah, super crazy, super weird, if there's some sort of like, what just happened? Always go back here and say, wait, did they plug in? And I think yesterday I even made a note of that. Because I said something about danger or watch out. Here we go. Watch out for the substitutions that are made with the OG. With the OG what? With the original function, with the original implicit function. If there's something weird that appears in the answer or disappears from the answer, maybe it's just math, like me reducing a 3 a second ago. A legal reduction. Or maybe it's a substitution from the original equation that there's no way you would have memorized. We're not going to memorize every single random equation they can throw at you. You just have to realize for an implicit differentiation, the original function could be used to substitute. Not in this one, though, because if you notice, neither of these show up down here. So it doesn't make a difference. Every now and then it shows up and people are like, what? It did some weird substitution. So, in this one, if there are y's in the derivative, they could plug in cosine of xy squared for that. Now, it'd be stupid because it isn't any simpler, but they could. Okay, can we do this one together?
Yes.
You guys see why it's jumbled, yeah? Oh, but
No.
mix that.
So many things.
Yep. So, we have to do d dx. Tell me, what rules do we need?
Is it product or chain?
Yes and yes.
Oh, it's both. Perfect.
And trig. Trig, product, and chain. Which one is the outside? Or the first thing for us to deal with? See them? Don't get tricked by the trig. No, don't worry. There's no square. There's no cube. There's nothing outside. It's just cosine. So if cosine is my outer, I don't even worry about the inner. Do I?
No.
Okay, what's the derivative of cosine?
Negative
You gotta know your trig rules. Negative sine of. Do I pop in yet?
No,
I keep it the same. Ooh, but now multiplication. I'm ready. Who's next?
Product rule.
There's your product rule. Now, just in case that's a lot, remember you could have off to the side done something like f is equal to cosine of u. U is equal to x y squared. So I just need f prime times u prime, which is negative sine of u, times, ooh, I need to take this derivative. You could have kind of split it up into different pieces, looking at the outside and the inside separately, but that's just a variation. It's not necessary. Either way, we have to do our product one. Oh, that's not funny. 10 years later. Okay. I'm going to put big old parentheses or else you're going to get in a lot of danger. I'm going to put big old parentheses or else you're going to get in a lot of danger.
Oh.
Second D first. Second?
Y squared.
D first.
1.
Plus first.
Six.
D second.
2y times dy over dx.
Y prime. U prime. Don't forget.
Y prime.
Equals dy dx. Why did I do a whole other example? If you're like, psh, whatever, take d dx, it's no big deal. Get the dy dx's on one side.
Because it's hiding inside.
Ah! Well, one of them's out, like, just clear, right? I see him. He's easy. But what's the hard one?
Inside.
He's inside. I need him outside. How do I legally get him outside these parentheses? What's the one thing I have to do?
Oh, no.
No way.
Yep.
Ugh.
Now, you're not going to like it, but guys, you're making it possible. Otherwise, it's impossible. You're getting to a right answer rather than just, oh, come on. You just don't like it, but you know how to distribute, don't you? Yeah. So just go ahead and say, all right, fine. Where would I put the y squared? In the middle, in the end, or in the beginning? Because it's a 1y squared. Where should I put it? Beginning. He's totally separate from the trig. I mean, he's multiplied, but he's separate. Does that make sense?
Yeah.
We would put any numeric coefficients, we put them in the beginning, we put any extra expressions in the beginning. Just leave that trig all alone at the end. But we have the next one too, which is going to be minus 2xy sine xy squared. See it?
Yeah.
dy dx equals dy dx.
Yeah.
Do you want to subtract the dy dx and try to save some time?
Sure.
Let's subtract the dy dx. Oh man, if I subtract the dy dx, I really want to put this guy on the other side. Ooh, I could add him to the other side and then be like, haha, look, I don't have to write anything. Okay, it's kind of cheating, I know. But I went ahead and got him to be negative, I added him to the other side, I subtracted him to that side, and then, haha.
Don't you want dy dx on the left side?
Well, yeah. But it's okay. Is it really a bad thing if it's on the right side? Can't I still factor? Can't I still divide? So if it helps, we have our y squared sine of xy squared that we added to the other side, just in an awkward way. We have our dy dx that I can now factor out of my negative 2xy sine of xy squared. Oops, I guess I don't need that parenthesis. Oh, I kind of did. It's sine of xy squared.
What is it, minus 1?
Minus 1. Just think when I divide by dy dx, a 1 is left. When I divide by dy dx, the whole block is left. Then I have to distribute to the other side. Now guys, would it make sense if the answer shows, make it match, dy dx is equal to negative y squared sine of x y squared all over positive 2xy sine of xy squared plus 1. Does that make sense?
Ooh, that plus 1 wasn't there because you were sine of.
I know, right? But since that plus 1 is there, it's stuck. I can't cancel. I can't kill kittens. I can't reduce the y. I can't reduce the sine because this is a binomial. And I can't factor anything out. But why is there a negative when there wasn't before? What did I do with this guy?
You divided it.
I divided it, and when I divided it, I took out the negative 1 and I moved it to the top. You see it? So if you want to think, I could have pulled out a negative, and I could have changed this to be a positive and a positive. Then I divide the negative, and then I divide the expression. Now, would it have been wrong if I had a positive and a negative negative? No, but would you have been able to make it match? Would you have pulled out the signs? Oh, along those lines. Here's a weird question. Ready? What if this was not a multiple choice answer, but what if this was? Speaking of signs and how things can get funny, ready? Here's another form of the answer. What if you had x squared minus y squared? They messed up! It's horrible! They failed! And down here they had 2x minus y.
That's true.
You see it?
Yes.
They pulled out a negative, which would flip. They pulled out a negative, which would flip, and those negatives reduced. What does that mean? That just means they could have moved stuff to different sides. We moved to left and right. They could have moved to right and left, and it would have looked like this. That's the struggle. You have this. This is also right. Or you have this. That's also right. And it depends on which way you move it. And there are technically two sides to an equation, and like Kyle and I just talked about, it actually mathematically doesn't make it wrong if I do move right. I just typically tell you guys to move left, but I was being lazy and didn't want to. Signs can get confusing, but if they get confusing, just think factoring them out. Okay, so we've done a couple examples of implicit differentiation, seeing how it gets hard. Okay, you can see how that one gets hard too, but let's go ahead and sneak, if you guys don't mind, sneak to the second derivative, because he's the second main concept, or he's the big idea that we have to cover here. And then I'll show you the trick with the other example as far as, oh man, do I always have to make these look nice? Because you're going to see in this one. Making him look nice is going to be a beast. You guys know how to find the first derivative, so when you're ready, find ddx on both sides.
Oh, in the middle. So, press it. So I don't. Time's your first thing. They're both my first choices.
Okay, we'll see what these steps mean and what on earth is going on. We see the directions, say find the second. We're like, oh, stink, that means we're doing more, right? But are we, you're welcome, are we just going for it? You can use Tyler's terminology, right? Just go for it. So for the first derivative, just go for it. 3x squared. We just did one of these a little bit ago. This one's actually easy.
Whoa, cheating.
No, I know, I was doing the product rule. I don't even know what from the last problem. I'm sorry. dy dx. Would you have made the mistake or not?
0.
Ooh, not one. You're going fast, you're going to put 1, and you're not even going to mean it. You're going to be like, what? I thought it. Oh. Okay, here's the dealio. Is this good enough?
Potentially.
No.
Because what am I supposed to find?
Second derivative.
What's the second derivative look like? Do we have this yet? Now, what do we have? Could we move all this over and get dy dx is equal to negative x squared over y squared? What'd I do?
You subtract and divided.
I subtracted and divided. Yeah, you guys see it?
Move quotient rule.
And I reduced my 3 over 3. Why is Kyle saying quotient rule? Because I have to find the next derivative. Now, I technically have 2 options at this point. I'm going to put a blank paper on the screen. There is another way that we could go. I'm going to get it ready. But I am going to go ahead and go quotient rule. It's what most of you guys would think with what you know. But there is another way, just for the record, there is another way you could go. But we're going to go this way. Where it's like, okay, let's go again. Let's go second time because that's where the second derivative is. So, ready? Go for it. As is. Wait a minute. Where does this notation come from? Do you guys see that d times d would be d squared if you were thinking of it that way?
Yeah.
And dx dx would be dx squared?
Wow.
Oh, it actually makes sense. It's the derivative of the derivative. Oh, and guess what would happen if you would take another derivative of a derivative? It'd be d cubed y over dx cubed. That's a third derivative.
That's
Anyway.
why it's green like that.
Yeah. Okay. But as Kyle said, we have a top and we have a bottom. You guys see it?
Uh-huh.
All right, bottom. D top. You guys are going to not do minus, so put parentheses or else everything goes bad, right? Minus. Top.
Negative.
Oh, that's nice. I can do plus, right?
Oh,
D
yeah,
bottom.
plus 2y.
dy dx.
dy dx.
All over.
Y. Quadruple.
You see it? Y squared squared. So y.
Can we get rid of the y squared?
No.
No, why not?
I think it's fine.
Because of the plus. You see it?
Yeah.
Now, is there, ooh, I do see a common y. We can't do that, right? But hold on, does anybody see the problem right now? Why do we have a complex fraction? We don't have a complex fraction. We don't yet, but we're sure about to. Why? When they ask for the second derivative, they want the second derivative only in terms of, if you look at their multiple choice answers, x and y, he doesn't belong. But it's okay. Look, we have him. Boop, boop. We know who dy dx is, so let's go get him and let's plug him in. Now we're going to have a complex fraction.
Oh.
We're going to have a complex fraction.
Yes.
We're going to have a complex fraction. But we're going to have them.
That's why we're plugging in.
Now some of you might be like, let's get rid of that y right now. But do you see who I see is coming? Maybe some y's are going to reduce anyway, so then we'll figure it out. Okay, if we plug in, oh, I don't want yellow. If we plug in, oh, I just lost it. We should see. Just kidding, don't see. Okay. Let's go. Negative 2xy squared, right? Make it all nice and pretty. Plus 2x squared y times negative x squared over y squared.
Yeah.
You have options. To make my life a little easier, I think I'm going to reduce the y's. You guys okay with that?
Yeah.
But what do we still have? What are the denominators?
Y.
How do we simplify complex fractions? Oh my goodness, this summer packet had a purpose! For those of you doubters. Times y. Be careful when you do times y over y. Don't we have to distribute it across that little addition that made it so I can't just go canceling? Oh, come on, it's not that bad. I'm just going to have negative 2xy cubed. I have to distribute that y. Plus, minus, because there's a negative, right? Minus 2x to the 4th. Because that y reduces when I distribute it a second time. And I have all over y to the 5th.
We're just collecting y's.
Y's everywhere. Now, looks pretty nasty, right?
I think it's good.
You think it's alright?
Yes.
So why would this be the final answer? Right about then you should be getting scared. You ready? Hold on. Dun, 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 dun. Woo!
Oh yeah.
Why? Should be totally confusing unless you wait. If something magically disappears, if something magically changes, if there is no mathematical reason, where did they look?
There.
What do you mean, where did they?
Well, if you take out a negative 2x, you're going to get y
Wait,
cubed
if I can
minus-
get, that's just a 1 and it might all go away? Check it. If you pulled out a negative 2x, wouldn't you get y cubed plus x cubed?
Aw.
It's like a magical formula I wouldn't have memorized, and I actually have to look at the problem and remember the beginning. Oh, just like I told you.
Like trig.
You have to go back and you have to look at the top. Kind of like trig, but trig we memorized that it could be off the top of our heads, theoretically. This one, it's a random, well, I don't know what x cubed plus y cubed equals unless I remember the beginning. And a lot of AP problems, they kind of get you distracted. You're way down here, and if you don't come back and remember your roots, ooh, there's a life lesson in this. If you don't come back and remember your foundation, remember the beginning, you might get way off track. What do you guys think? Could you do it? But you're going to notice it, because when you go to make it match, you're like, what the? That makes no mathematical. Ding, 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 ding. Go back. Maybe. Not always. Maybe. Either it's trig and they did something funny, or they did a weird substitution, or you're way wrong. There is a variation, real quick. The variation is instead of going quotient rule, what we could have done is we could have taken this guy off to the side and just pulled a Tyler. Just gone for it. Wait, just gone for it? How do you just go for it if you hadn't gotten dy dx by itself? Sorry. Can't we just start taking another derivative? What if we had never made it look pretty?
I don't know, I kind of like making it pretty.
I think I do too, usually, especially if it's an FRQ that says do this first, then do that. Well, I kind of have to do that anyway. But couldn't we have just made 6x? Does that sound nice to anybody? Couldn't we have just made 6y dy dx? Wait.
Times dy dx.
Wait. Times. Whoo, 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 little cheaters.
Yeah, no.
Little cheaters.
I'm not
Well, you had to do a quotient line. But if you had gone to do this, it's a variation. It's another way of going besides don't choke on your coffee. Besides the quotient rule, you could have done second, d first. There's 2 of them plus first. Wait, how do I take a derivative of a derivative? There's a name for that. Huh. Guess what the name of the game is now, guys? Derivative of 0 is 0. Who am I supposed to get by himself?
D squared.
But could I plug in dy dx? You're going to have to plug in dy dx no matter what. Sometimes once, if you do it this way, you might have more than one you have to plug in. But you could have plugged in your little negative x squared over y squared. You could have maybe simplified some things here, maybe gotten some common denominators, maybe moved it in a way that was easier, maybe not. But either way, you'll get the exact same expression. You'll solve for this dude, and then you'll have him. Now, here's a question. What if, in kind of using the example that I totally skipped a second ago, what if they said something like, find the second derivative at the point one half. Oh, this is bad. 0, 1. Sorry, I had to actually give you a point that worked. If x is 0, then y would be 1. I just had to give you one that worked. Sorry. What if they said something like find second derivative at the point 0, 1? Would I have to make this pretty? That's the cool thing with implicit differentiation. If you're not just finding the general derivative, first derivative or second derivative, you don't have to make it pretty. The example that we skipped, so that you guys can start on homework in like a minute, the example that we skipped said just find the slope. If you just find the slope, you don't have to make it pretty. On this one, that's disgusting. I would go ahead and I would take this derivative, 2x plus 8y dy dx. Would you have made the mistake, or would you have put the 0? But then I would have just said, maybe you could rearrange it or just plug it in as is and say, forget it. I just want the slope. Haha, plug it in, plug it in. So I would get 2 times root 2. I would get 8 times, well, actually, negative 8 times 1 over, ew, that's gross, dy dx. But how would you finish? The same way that you would have done up here. Get dy dx alone, get dy dx alone. You can do that first, or you can do that later. Either way, you're going to have to do it. If I did it this way, I could subtract the 2 root 2, I could divide, so I would end up with 2 root 2 with a negative times the reciprocal of root 2 all over negative 8. Some of you are going to like the numbers a lot better than the variables, so instead of making this a nasty quotient, you might have just wanted to plug in and then deal with it. It actually will save you from having to simplify a complex fraction, so I should probably finish it. That'd be 1 over 4, that'd be 2, and 2 over 4 is a 1. That might take me a little bit of time. That's okay. You don't technically need to do that example unless you want to. I'll put it back up on the screen towards the end if you guys want it. But the long story short is, what if they just say find a second derivative? Would I have to make this pretty? No. I could just go ahead and say, okay, if this was the point, I could just go from here and say, plug it in like 6 times 0. dy, wait, who's dy d? Oh, got him. What's negative 0 over y squared? 0 times 6 times 1. Doesn't matter. 0 times negative 0 over y squared. Doesn't matter. 0 plus 3y squared. That'd be 3 times 1 squared times dy dx. Sorry, second derivative. Equals 0. Well, then I just have 0. Forget that. 0. Forget that. Then I just have 3 d squared y dx squared equals 0. What's my second derivative? Anything divided by, or sorry, 0 divided by anything is 0. And I wouldn't have even had to make it look pretty. So, implicit differentiation, if you have to do it, but you get to plug in a point, you don't have to make anything look pretty. We only make it look pretty when we need to make the derivative match with like a back of the book answer or a multiple choice question. With that, kiddos, yeah, we're going to leave off logarithmic differentiation because the notes that I gave the underclassmen didn't have this. So we'll just stop there. There was one more example that we could have done about finding the second derivative, but I don't think they would have gotten that one done in the notes in the video either, so we're going to stop. Okay, there you go. Second derivative will be our warm-up for the morning as we're going over homework. If you guys see anything that says log, use log, just stop. It says logarithmic differentiation. Or use logarithms in homework tonight. Stop, submit your homework, and say, I'm good. And I'm going to go ahead and put a comment on your homework assignments that the underclassmen kids know what to do. All right, you guys have the homework? Here's that example if you want to write it down, the one that I did really quickly. But otherwise, here he is if you want to work. Go for it. Let me see where you get to stop it from there. We are at section 2.5. You guys don't need to go into the 60s, like maybe number 60, 60, but not 61, 62.
Just got dramatically.
So where does that stop you? Woo! Look at you guys! You get to stop right here. Is this section 2.5? That's right. You get to stop right here after number 54. Sound good? Go team. I'll put a comment.
Wait, 63 or 66?
No, you just do the
Stop at 54.
You get that? I have a B in AP Lit now. I'm so happy.
I have a B on the precipice of an A. And like
Well, I have a B on the precipice of a C, so.
why would you?
64? No, I had a C. And then I 64% from B. Along with all the classwork we've been doing.
That's what I got.
You know?
I'm afraid I don't even have a B or an A. Do you have a B or an A?
AP Lit?
Yeah, how can you guys not have these?
Because essays are
Essays,
a lot and
and
she's
they're
a hard
tough.
to
She's tougher than the AP graders. She grades like a college teacher.
That's good though.
I have an 89.58 and it's marked as a B.
Because A's are supposed to be excellent work, and so she's like, well, you gotta keep
Well,
working
she's
towards
actually
that.
been really nice with the essays right now.
Oh,
She's
she
doing
is?
this half. She's making it half. So I
Oh,
understand out of 100 points, out of 50 points.
okay. But it still can be brutal.
Just like the scale she's doing.
Yeah, but once that is
Is it scary for you guys?
There's no reason. It's just gonna be.
It's not gonna be in class, is it? It's
What?
Like, she's gonna do like a time-page research paper.
No, it's not final.
That's what she said.
That's her second semester project.
We said we're doing that in December.
No, she's doing it so it can be used in January.
Oh.
Okay, period 1 and period 6 both got the comments. That way everybody knows stop at 54. Get through 54, but then you can stop.
So like our final is probably gonna be an essay question which we've done before already.
Tomorrow is how much?
Friday.
I didn't something.
She gives us an essay every other week. So on the
Mr.
weeks.
T wants to do like a slam poetry night. Like, he wants if you would do it. He said.
No way.
Yesterday, we were like,
Like a poetry reading?
yeah.
That'd be cute.
Yesterday, we were saying.
I feel like a
lot of people would do that.
We were just talking about AP Bio. I'm just like, Mr. T is actually so funny. And he's like, aren't I funny? Or something. Like, it was funny.
Oh, it makes it cute.
We
We should so hard.
Kitty.
No, you're not kidding.
What would his girlfriend think?
He's a girlfriend.
Yeah, Mr. T's dating someone.
Last year, I remember
He was dating someone last year,
always
too.
he said that like your girlfriend was too good. They said he apparently was dancing, and then like they asked him like a month later, and he was like, no.
Yesterday, he was dressed so nice. Mr. T, I like the fit. And he was like, you know, it's whatever. I was like, because he has this class that tells you what training that he teaches. And so we're all going to go, and we're going to get CPR certified because he's getting a certificate.
What the heck?